Hey, this is Mr. Warden. This is the Algebra Exit Ticket 33.1 video key. So let's do this. We've got this question. What are the x-intercepts of y equals x squared minus 7x plus 2? To find the x-intercepts, one of the key tools we have in our tool belt is to factor it and then use the zero product property. So to factor this, I need two factors of 12 that add up to -7. And two factors of 12, so there's factors of 12 that easily add up to 7, 3 and 4. But if we make them -3 and -4, they will do the job. So we can just say y equals x minus 3 times x minus 4. And if we want x-intercepts, then we want y to equal 0. So let's do that. Set y equal to 0. Okay, if y is 0, then one of these factors has to be 0. So either x minus 3 has to be 0 or x minus 4 has to be 0. So you want to ask yourself, what would I subtract 3 from to get 0? Well, you could subtract from 3. Okay, so I'm going to subtract 3 from 3 and get 0. Or I could subtract 4 from 4 and get 0. So my x-intercepts are based upon that. My x-intercepts are going to be 3, 0 and 4, 0. Those will be my x-intercepts. Y-intercepts, on the other hand, in my next question, require me to figure out what y would be when x is 0, because the y-axis is the vertical line at x equals 0. So I'm going to take this equation. Now, once you get the pattern of this, it'll be really easy. But I'm going to take this equation. I'm going to go through the process. I'm going to replace x with 0 wherever it shows up. So x will be 0 there, and x will be 0 there. And hopefully it's pretty clear to you that that means that y will equal 12. But here's why. It'll be that 0 squared will be 0 minus 7 times 0, which will be 0 plus 12. So all that's left standing is the 12. So y will equal 12 when x is 0. And so the y-intercept is 0, 12. Now, let's take a look at number 3. What would be a simplified version of the square root of 32? So we can find some perfect square roots within 32. Okay, so we're getting the square root of 32. And of course, it's going to be a plus or minus affair, but there it is. But 32 could be broken into 16 times 2. And 16 is a perfect square. So plus or minus the square root of 16 times 2, which is going to be plus or minus the square root of 16 times the square root of 2. Now, the square root of 2 is not reducible. You're going to have to write forever. It's an irrational number that starts with 1.4, and you will be writing forever and forever because it will never end. But the square root of 16 is neat and tidy. That's either 4 or -4. So I can write plus or -4. That way I know that I'm using both. And then that's going to be times the square root of 2. So the square root of 32 is plus or minus 4 root 2. And so that's this one right here. We're going to factor this one. This is a level 5 or level 6 question, but really what you've got a perfect square here, you got a perfect square here. And this middle term, 14x, is the square root of this times the square root of this times 2. And so we call that this middle term confirms that this is a perfect square. So we can factor this as x plus 7 times x plus 7, which will be x plus 7 squared. And just to confirm that, I'll rewrite it as two binomials next to each other, x plus 7 times x plus 7, and that's going to equal x squared for the x times x. And then the 7 times 7 give us a plus 49. And then we've also got a 7 times x and x times 7. So we've also got a 7x plus 7x plus 49. And the 7x plus 7x becomes a 14x. And that is our perfect square. So we can factor it simply like this, x plus 7 squared. All right, I hope that was helpful.